In today's question, we are asked to find the size of angle y. And they said the quadrilateral PQRS is a parallelogram, meaning this line here, PR is parallel to this line QS. And this also here, PQ is also parallel to this line RS. So they said the circumference of this circle here is equal to 9.43 centimeters. And this line here is 4.3 centimeters. So how can we use the given information to solve for y? Since we know in a parallelogram, opposite angles are equal in size, that means this angle and this angles are equal because they are opposite to each other, and hence this is also equal to y. So we write y here as well. Now coming back to the circle here, line PR and line QS are tangent to the circle. Recall the two lines are parallel to each other, and that means the distance between the intersecting point of the two tangents and the circle is a diameter of the circle. So that means this line here is a diameter of the circle. But remember, they said the circumference of the circle is 9.4 centimeters. And the formula for the circumference of a circle is 2 pi r or pi d. So since we are dealing with this line here and the line is a diameter, we can choose to use this pi d because d equal to diameter. Equate pi d to 9.4, so pi d will be equal to 9.43. But here pi is given to be 3.142, so we can substitute directly. Now 3.142d equal to 9.43 centimeters. Dividing both sides by 3.142, here 3.142 will cancel 3.142, while here 9.43 over 3.142 is equal to 3. Now we find the diameter of the circle to be 3 centimeters. So if you look now, just as this line is a diameter, it is also the distance between line PR and QS. And we know the distance between any two parallel lines is always the same at all points. And that means the distance from here to here is also the same distance from this point to this point as well. So this is also 3 centimeters as well. Here is a right angle, and hence this triangle here is a right angle triangle. Now to find the size of angle y, we apply the right angle rules to this triangle, the SOHCAHTOA. Now from angle y, this line here is our opposite, which equals to 3 centimeters, while this is our hypotenuse, which also equal to 4.3 centimeters. So from this here, sine theta equal to opposite of our hypotenuse, where theta is y, so this will be sine y. Opposite is equal to 3 from here, so this is 3, while hypotenuse equal to 4.3. So substituted, this will be equal to sine y equal to 3 over 4.3. Now 3 over 4.3 is 0.6977. So sine y equal to 0.6977. To find the exact value of y now, y will be equal to sine inverse of 0.6977, which equal to 44.2428, approximately equal to 44 degrees. This here we can see is a right angle triangle with a surface area of 32 centimeters squared. We are asked to find the length of this side here with the question mark on it. So how can we solve this? This is very simple. Since here we already have the surface area of the triangle to be 32 centimeters squared, and the formula for finding the surface area of a triangle is half base times height, we all know. We can equate half base times height to 32 centimeters squared. Now 1 over 2 b times h equal to 32 centimeters squared. Recall, in a right angle triangle, any of the two sides that are perpendicular to each other can be the base or the height. That is this side and this side here. We don't have their length, but recall here, we have that this angle A is equal to this angle B. So we can replace this B here with A. Now, sum of the angles of the triangle and equate to 180 degrees, because the summation of angles in a triangle is 180 degrees. Summing up now, 90 degree plus A equal to 180 degree. A plus A is 2A, so 90 degree plus 2A equal to 180 degree. Subtracting 90 degree from both sides and dividing both sides by 2, now A equal to 180 degree minus 90 degree over 2. 180 degree minus 90 degree is 90 degree. 90 degree divided by 2 is 45 degree. So A equal to 45 degree. Substituting here and here now. Now the fact that the two angles are equal in sizes tells us that the triangle is an isosceles right angle triangle. And we know that in an isosceles right angle triangle, the sides perpendicular to each other are equal in length, which are this and this here. So let's label them x. Now coming back to this equation, recall we acknowledge that these sides are the base and the height. So we can go ahead and substitute x and x here. Now 1 over 2 times x equal to 32 centimeters squared. 1 over 2 times x sin x is x squared over 2. So x squared over 2 equal to 32 centimeters squared. The cross multiply, since 32 centimeters is the same as 32 centimeters squared over 1. Now x squared times 1, which is 1, equal to 2 times 32 centimeters squared, which is 64 centimeters squared. So x squared equal to 64 centimeters squared. To find the exact value of x, we find the square root of both sides. Now square root of x squared equal to square root of 64 centimeters squared. Square root of x squared is x, and square root of 64 centimeters squared is 8 centimeters. So x equal to 8 centimeters. Substituting here now, to find the length of this side here, we can use the Pythagoras theorem, which says the square of the hypotenuse of a right angle triangle is equal to the sum of the squares of the two other sides. The hypotenuse is the side facing the right angle, which is this here. Now applying the Pythagorean theorem, hypotenuse square equal to 8 centimeters squared plus 8 centimeters squared. 8 centimeters all squared is 64 centimeters squared. 64 centimeters squared plus 64 centimeters squared is 128 centimeters squared. So hypotenuse square equal to 128 centimeters squared. To find the exact value of the hypotenuse, we find the square root of both sides. Now square root of hypotenuse square equal to square root of 428 centimeters squared. Square root of hypotenuse square is hypotenuse, and here square root of 428 centimeters squared is 11.3137 centimeters, which approximately equal to 11.31 centimeters. So hypotenuse, which is this side here in question, we found to be 11.31 centimeters squared. Thank you for watching. Please subscribe, like, share and comment.